Um, I'm Newton Magna, a co-founder at Be Audacious, among Ivy and Abigail. I'm beyond excited to welcome you all to our first event of the year. It's incredible to see so many passionate and driven individuals gathered here, ready to embrace bold ideas and to take on new challenges. A little bit about me, in my final year at KC University, studying software development, and I've always believed in the power of innovation, collaboration, and stepping outside our comfort zones. And that is exactly what Be Audacious is about. It's about creating a space where we can push boundaries, where we can support each other and make an impact. So let's connect, let's share ideas, and let's make this an unforgettable experience all throughout the year. Welcome to Be Audacious. I'll pass it over back to Ivy. Thank you.
Okay, thank you for that introduction. So, our main aim is to introduce people to like tech to foster that community of beginners in tech. And you understand it can be a little bit scary or intimidating, but it's not that bad. Trust me. So, I'd like to acknowledge our speaker, Farah. But before that, I'd also like to acknowledge Geeksters who are also the partners or a collaboration. Um, they were with us last year and we are still together this year. So I'd like to have like a short word from Monica Wamuhu.
Thank you for the opportunity, Ivy. My name is Monica Wamoho. I'm a software engineering student at Multimedia University, also a co-founder of Geekstars. We are glad to partner with Be Audacious on their series of webinars. I'm so excited to learn about AI/ML today and also attend the upcoming webinars. I'm sure there's going to be more. Yeah, thank you so much.
Amazing. So I think at this point we're going to pass it over to our speaker of the day, Farah, and he's an AI ML engineer and he has done a lot of work regarding AI ML, and I hope we get to all learn. And yeah, don't be afraid to ask questions and to be interactive throughout the session. So over to Farah.
Hi, can you hear me?
Yes.
So, yeah, I was just fixing my audio. So, hi guys, let me see if I can turn on my camera. Hope you can be able to see me. Yeah, so hi guys. This camera I'm just going to turn it for a while because of network issues. But my name is Farah Abdi. I am a former student at KCA University, and I'm also a machine learning engineer. And I love AI and machine learning engineering, and it's something that has been my passion since I started in tech. So first of all, I want to say thank you to the community for them inviting me to this talk, and I really appreciate for them taking me as an expert. You know, it's an honor, right? So today, like Abigail said, I'm just going to do an introduction to artificial intelligence, machine learning, maybe do a little bit of prompt engineering, and just what prompt is. You know, people hear about prompt engineering and think like it's something scientific, but not. It's just anyone can be able to do it. So without further ado, yeah, and if you have any question, feel free to interrupt me. I have no problem someone interrupting me. Feel free to interrupt me. Feel free to say something in the chat. Feel free to raise your hand. Don't be afraid to ask questions. Yeah. So let me share my screen. So yeah, I hope you guys can be able to see my screen. So I think we can be able to start. So this is just an introductory level to machine learning and AI, and I'm not gonna go to the nitty gritty, the technical part of it. I'm just gonna give you an overview of what artificial intelligence actually is. So, simply put it, the AI is something that imitates human behaviors and capabilities, right? So, just put it as like, for example, you want a computer to be able to understand and visualize image the same way you as a human being, when you see someone, when you see your friend, or when you see someone, you can be able to know who the person is. And if you don't know that person, you can be able to know the person taking that data, and the next time you see that person, recognize the person. So it's just the ability of a computer to actually have an understanding of, what, or imitate what human beings can be able to do, right? So there are several workloads or things that are under artificial intelligence, right? So machine learning is one of it. So this is the foundation and the fundamentals of artificial intelligence, right? It's just the ability of, or the way we actually teach, a computer, right? How to imitate. So we teach a computer model to make prediction and draw conclusions from data. So we enable a computer to understand data and actually predict us something, right? So that's what machine learning is. And there are different categories of machine learning, which I'm going to go through about it. And then we also have what we call computer vision. I'll just explain an example. This is the ability within artificial intelligence to interpret the world visually through cameras, videos, images, right? For example, I said, like, you when you have a face ID, right? So a computer understands your facial features, or a traffic light or a traffic camera system, like the way these modern or first world countries have. Like, it's this system that can be able to actually get your plate and all that. So it's ability of computers, or to be able to interpret and understand uh, the world visually through cameras, images, videos, right? And then the other category that we have is natural language processing, whereby this is the capability of of a computer to be able to understand natural language. And what are natural languages that us human beings have? It is either spoken through speech, or it's either spoken or through speech, or it's either through writing, right? So we can either write the language we understand, or we can either speak the language we understand. So a computer cannot be able to understand, right, natural language. So natural language processing is the ability now to make this computer understand the natural language that us human beings have. It converts this spoken word or written word into a way that machines can be able to interpret it. And then we have document intelligence. This is the capability within artificial intelligence that deal with managing, processing, and using high volumes of data found in forms and documents. So we want to understand these documents that maybe an organization has, right? So organization has, let's say, an organization, the government, it has large amounts of documents that are manual, and we want to make this document, to arrange them, process them, and make them ready to be able to be interpreted by artificial intelligence. So this is what document intelligence is. And then knowledge mining or AI search, it's the ability now for artificial intelligence to extract exact or accurate information from large and often unstructured data. Let's say, for example, you have a chatbot that interprets that has been integrated into the HR policy of an organization, and you want this chatbot to understand the leave policy, leave days, sick days, payment policies of the company. So this is the ability to be able to give artificial intelligence, and it can be able to extract exact information from these large samples of data. And then the last one, which it's common to all of us, when they were introducing the session, they mentioned DeepSeek, they mentioned OpenAI. So this is generative AI, which has taken the world through a buzz. Is the capability within artificial intelligence that creates original contents in variety of formats. So, for example, a ChatGPT, it can be able to create original content through natural language, which you through text or speech, or image, or code, and even more. Right. So these are the categories that form the bigger chapter of artificial intelligence. So we're going to try and just understand what these different categories are actually are. So let me take you through machine learning and share my present something else. So let us go through understanding. I can't be able to find it, but yeah, we can just continue with this one. Understanding machine learning. Now, we can take a look at this video and maybe have a bit of a...
Right now, artificial intelligence helps us meet the needs of today so we're prepared for tomorrow.
By 2050, we need to produce 60% more food. So how are we going to feed the world without wrecking the planet? Using Microsoft artificial intelligence, we can reduce waste and produce more food. Any grower will tell you every row, every crop is different. We can use Microsoft AI to make local predictions about light, wind, rain. This helps farmers know when to plant, irrigate, and harvest. It's making a difference.
Artificial intelligence helps farmers grow more while wasting less.
So now machine learning is the foundation, like I said, in artificial intelligence. So how does it work? The answer is from the data. So we create a lot of data as we go about everyday life. Now, data scientists can use all this data to train a model that can make prediction and inferences based on the relationship they find in the data, right? So machine learning models, what they typically do is that they try to capture the relationship between the data. Let's say, for example, a good example I can give is, let's say, let me give a good example when you were in high school, right? Let's say now our high school wanted to predict the grades that we were going to get in KCSE. Like we've started from 4, and then, so what they're going to do is they're going to take the data for our mock exams on different exams that you have done, right? So we have this data, right? And they're going to give a model and train the model using this data. So what the model is going to do is going to understand the data and identify patterns, and then we're going to try and predict the grade that someone is going to get in their final exam, right? Now, this is machine learning. The key, as I said, is data. So I'm going to show you the different parts or the different types of machine learning. Now, what are the different types of machine learning? So we've talked about the machine learning in general, right? But there are several parts in machine learning. The two main categories of machine learning is supervised machine learning and unsupervised machine learning. Now, under supervised machine learning, we have regression and we have classification, and we're going to go through what this is. And under unsupervised, we have clustering. Now, what is supervised machine learning? This is a general term. Just what we do is we train data. The data includes both the features and the non-label values, right? For example, you're trying to train a data to be able to understand people who are diabetics. So this data has features that can lead someone to have diabetes, and then the label of these features, it has a label that these parameters, or for example, if someone has this insulin level, pressure level, or something like that, is going to lead someone to have diabetic. And this one is going to lead someone not to have diabetic. Or another example is, for example, let's say we have, for example, let's say Shiko, his style wants she wants to understand the sales of her shops in Nairobi. So what is she going to do? She's going to create a model that takes in data of the previous months, right? And then this data, for example, you say, okay, this day one, or this Monday in December, we did this sales, and this was the total sales. Tuesday in this December, and then January, it has this, and then it has a labeled value, right? Non-label value, right? So she's going to train the machine model with this data, and the output she's going to get, and then when she wants to predict, she's going to use this model to predict her future sales for maybe March, right? So there are different categories to supervised machine learning. The first one is regression. And regression is a form of supervised machine learning in which, what do we do? The label predicted by the model is in a numeric value. And this is a big difference that we need to actually understand and comprehend. So for example, the selling price of a property based on its size in square feet, the number of bedrooms it contains, and economic metrics, right? Or the number of ice creams sold on a given day based on temperature, rainfall, wind speed, right? These factors like temperature, rainfall, and wind speed is going to give us the sales of that ice cream in that given day. And with like 60 days, we're going to give these 60 days to the model and train the model to understand, and then we predict the number of ice cream we're going to sell next week, right? That's regression. The label predicted by the model is a numeric value. That's what you want to understand. The prediction is always a numeric value. And then we also have classification. This is a form of supervised machine learning whereby the label represents a categorization or class. For example, the cliche categorization is maybe this is high class, middle class, low class, right? But so the two common this is classification is, for example, these features, these several features, for example, we are predicting someone if he or she is diabetic or not, right? So there are metrics that you're going to see. So the weight, the age, the blood, the glucose level, and so on. So these features is going to give us either or, right? Either this person can be diabetic or not, right? So the classification simply it categorizes the output into categories, diabetic or not, or maybe this soil can have this and this and this, right? Now, under classification, we classify, we categorize or class scenarios. Under classification, we have two types of classification: binary classification and multi-class classification. From the word binary classification, we are able to just get from the word binary. Binary is two things, either 0 or 1, or either this or that. So binary is just predicts one of two mutually exclusive outcomes. Now the example that I was using, which is a diabetes example, whereby we want to know whether a patient is at risk for getting diabetes or not. So there are several metrics or factors that can lead to someone having diabetes or not. So like weight, the age of that person, the blood glucose level, and so on, right? So these factors are going to tell us if this person either has diabetes or not. Or another good example is a bank. For example, banks, when they want to give you loan, they have some risk metrics they want to check, right? So someone can either be a high risk person who can, when that person is given a loan, there's a high possibility that person won't pay back. For example, if someone doesn't have any income, right, is unemployed, his credit history is bad, age, for example, the person is young or a student like me, or unemployed, right? So these factors is going to lead to you maybe not being given a loan. Or if someone has a good income, has assets, has a good credit history, is older, right? This factor is going to lead this person to be given a loan. So it's either yes or no, right? So that's binary, true or false, positive or negative, 0 or 1, yes or no. And then multi-class classification extends binary classification to predict a label that represents one of multiple possible cases, right? A good example is Netflix. When they want to categorize movie, they categorize into different categories: comedy, horror, romance, action, adventure, sci-fi, and all that, right? So you might watch a lot of horror movies, and then you are being categorized in the horror section. You find the recommendation you get is for the horror movies. Or, so in simple terms, multi-class classification, it has several multiple possible cases. You might love horror, you might love romance, you might love adventure, and all that, right? So in most cases, that scenarios that involve a known set of multiple classes, it's used to predict mutually exclusive labels, right? So that is classification. Anyone who has a question up to there, you can throw in the chat. Okay, if there's no question, we can move on. Now, we go to the next part of machine learning, which is unsupervised learning. Now, in unsupervised learning, we have only one. So unsupervised learning, machine learning, what is it? It involves training models using data that consists only of feature values without any known labels. So when you encounter a data that doesn't have labels, or maybe these features doesn't end up to giving you a label, that is unsupervised learning. For example, you're given data of someone's data bundles buying habits, or someone's bundled buying habits, right? So there are people who buy lots of data, there are people who buy very few data, but it doesn't have an output. It doesn't mean that when you buy more data you do this. No, it's just that it has features, right? So the most common form of unsupervised machine learning is what we call clustering. So it just identifies similarities between observations based on their features and groups them into discrete clusters. Let me give you a good example of back here at home. Safaricom, when they want to categorize us maybe in a data bundles buying habits, you find someone like me who doesn't buy a lot of bundles. I might be given maybe bundles, maybe 10 GB, 10 shillings, I get 1 GB. And someone who buys a lot of bundles, he can't get that, right? So maybe you might categorize into the broke area, the people who buy more data, right? Something like that. Or a company, the marketing team wants to see, like, let's say Zuku, or a company wants to see your internet usage service or something, your usage of their product, right? So they're going to categorize. I've got a good example: Bolt or Uber. So sometimes you see that you haven't used Bolt for a while. Maybe you're people like me who are Futsubishi guys. So you find that they tell you, okay, come back. They give you a 20 or 30% discount, right? And then you find someone who's been using Bolt a lot. Sometimes they give you also a discount. So what they do is they categorize into different categories. Someone who doesn't use the product at all, someone who uses maybe at a minimum, someone who uses a lot, right? So it's going to help the marketing team gauge how to deal with this different type of customers. They see, okay, this person who is using our app a lot, we need to retain this customer. What are we going to do? What we're going to do is we're going to give him a discount. And this other customer who doesn't use our app, how are we going to get this customer to use our product more frequently? So give that person a discount, or maybe give that person a free ride, something like that. So that's what clustering actually does. Anyone has a question in the fundamentals of machine learning? I wanted to emphasize on machine learning more since it's a very important topic. Anyone has a question? If no one has a question, if no one has a question, we can dive into computer vision. Let me change my screen. So let's see this example of so computer vision, like I said, is the ability of AI to interpret visually, right? So images, right? Videos. So let's see this.
Seeing AI is a Microsoft research project for people with visual impairments. The app narrates the world around you by turning the visual world into an audible experience. Point your phone's camera, select a channel, and hear a description. The app recognizes saved friends.
Jenny near top right, 3 feet away.
Describes the people around you, including their emotions.
28-year-old female wearing glasses looking happy.
It reads text out loud as it comes into view, like on an envelope.
Ken Lawrence, P.O. Box.
Or a room entrance.
Conference 2005.
Or scan and read documents like books and letters. The app will guide you and recognize the text with its formatting.
Top and left edge is not visible. Hold steady. Lease agreement. This agreement
When paying with cash, the app identifies currency bills.
$20.
When looking for something in your pantry or at the store, use the barcode scanner with audio cues to help you find what you want.
Campbell's tomato soup.
When available, hear additional product details.
Heated microwave bowl on height.
And even hear descriptions of images in other apps like Twitter by importing them into Seeing AI.
A close-up of Bill Gates.
Finally, explore our experimental features like scene descriptions to get a glimpse of the future.
I think it's a young girl throwing a frisbee in the park.
Experience the world around you with the Seeing AI app from Microsoft.
So yeah, that video just gives us a bit of understanding on computer vision. So computer vision has several capabilities, and I'm just going to quickly go through it. The first one may be most computer vision solutions are based on machine learning models that can be applied to visual input from cameras, videos, or images. So these are several tasks that computer vision models actually do. The first one is image classification. Like you want to train a machine learning model to classify image based on their content, right? So for example, like this traffic monitoring solution, you can use an image classification to classify images based on the type of vehicle they contain, maybe taxi, bus, or a bicycle. And then we have another one called object detection. So these models are trained to classify individual objects within an image and identify their location. So let's say, for example, using this Seeing AI app, a blind person wants to use this. So when someone is wearing maybe some smart glasses, this object detection model can be able to detect an object at a certain distance and tell you, okay, in 500 meters, there's an object, there's a chair, or there's a blockage or something. Please avoid it, something like that. And then we have semantic segmentation. Like this is advanced machine learning technique in which like individual pixels in the images are classified according to the object to which they belong. And then we have image analysis. Again, for a blind person, you can be able to wear the smart glasses and actually analyze what is in front of you. It might tell you, okay, in front of me there is a chair and a glass of wine, or some a TV, watching Netflix, something like that, or a dog who's wearing this. Like it describes your surrounding, right? And then after image analysis, we have face detection, analysis, and recognition. This is a specialized form of object detection. What does it do? It locates human faces in an image. So this can be able to, for example, what is it called? The face lock, right? It detects a face in the image and it detects facial geometry on your face, right? And then optical character recognition. It's a technique used to detect and read text in images, right? For example, you might take a photo of a sign and it reads the text and it directs you to maybe Google Map, and then it tells you, okay, this is this and this and this, right? So that is computer vision. And lastly, I wanted to talk about generative AI, and I do a demo on prompt engineering, a short one. So generative AI, like I explained, is just a category of capabilities within AI that creates original content. So maybe if I get another session, I'm going to explain the technology or the workings of generative AI, large language models, how it actually works, right? Abigail, how many minutes do I have?
Around 20.
20. Okay, that's okay. Thank you. So I'm going to finish up. So generative AI, like I said, is just creates original content, code, natural language, image, and audio, right? So yeah, what I'm going to do is I'm going to take you through just the basics of how this large language model works, just quick. Now, hope you can be able to see, right? So, how does, for example, ChatGPT works, or GPT, like we say, generative pre-trained transformer work, right? So, the first thing it does, you have a tokenizer. What's tokenizer? Like, it's just converting text to numbers. So it receives a text as input and generate a text as output. However, like when you want to, these models, they work much better with numbers and text sequence than text sequences, right? So that's why every input in the model is processed by a tokenizer before being used by the core model. A token is just a chunk of text consisting of a variable number of characters. So for example, we have let's say for example we have this uh, what is a tokenizer, right? So it's broken into different tokens. What, we convert it into this token number, is token number, token number 257, token, this one, ISA, and then the question mark. Like all of this, we convert it into token, and this enables then each token is able to be mapped with an index, which is is the integer encoding of the original text chunk. Like this is just an integer encoding of the original text chunk. So this one just represents the word what is a tokenizer, but in numbers where a machine can be able to understand. Now, given an n token as input, right, the model is able to predict one token as output. This is then incorporated into the input of the next iteration in an expanding window pattern, enabling a better user experience of getting one or multiple sentences. Right. So this token is, in simple terms, it's we work with the relationship of this token, and it's broken down. It's much more complex, and when I get another chance, I'm going to break down on what tokens is, what embeddings are, what and how are these placed in a vector space, things like that, right? So, and then selection process and probability distribution. So the output token is chosen by the model according to its probability of occurring after the current text sequence. Why? This is because the model predicts a probability distribution over all possible next tokens calculated based on the training. However, not always the token with the highest probability is chosen from the resulting distribution. So a degree of randomness is added to its choice in a way that the model acts in an undeterministic fashion. We call it the temperature. We do not get the exact same output for the same input. So this randomness is added to simulate the process of creative thinking, and it can be tuned using a model parameter called temperature. So maybe if I get an opportunity, I'm going to break down what these parameters are. And yeah, so before I dive into a short, quick demo, anyone has a question up to that? Someone saying, I think I will get a smart glasses and go to the example. Oh, my lecturer is not here. I don't think a lecturer can come into this fun session. But yeah, he's not going to catch it, don't worry. So I'm going to finish up with this quick thing called prompt engineering. Share this window instead. A minute. So I'm going to quickly go through prompt engineering. This is for everyone, right? So sometimes we use these generative AI models, and we don't know how to work with it. We don't know how to actually get the correct answer from it. So these models are stochastic. They can fabricate responses, and this model do not have memory, right? So what is prompt engineering? It's just the ability of you how you structure your prompt to be able to get the answer you actually, or the task you actually want from the model. So for example, there's what we call system message. They have a task, right? You have tone, guidance about the tone and style of responses. You have safety guidelines. You have context. You give the context. You have conversational history. But this one you can implement it in your background. But my main essence is for you this one here. Give your model clear instructions. Imagine you are speaking to an untrained intern or someone who doesn't know anything. So what do? Avoid assumptions. Provide contextual specificity for the task the model should actually perform, right? Just don't beat around the corners. Just go straight to the answers. Again, break down requests. Use techniques such as chain of thought to break down complex tasks into several instructions. For example, you say, "Hi, my name is this one," and not my name. Sorry. Say, "Hi, I want to do the following." So first thing, do this, and then okay. After that, do this, do this. Break it, right? And then provide details. Give enough details, right? Just don't give what we call few shots. Let's give don't give one shot prompting, just give like things like few shot prompting whereby you give it a lot of details to be able to understand what you actually want, right? So I want to do a quick demo. Mhm. So this is just, I'm going to use this playground. So the task I'm going to give, I'm going to give my model a task, right? Let me go to the playground. I'm going to give the model instruction. So you are a web copywriter for this outdoor company. Your goal is to generate the website copy for the homepage. Your answer should be brief and engaging. Always use a friendly and professional tone of voice. Always show the word this one in capital letters. You might also come and say, you are an exam or you are an exam helper, right? So your goal is to understand the questions papers that I give to you and give me answers. Your answer should be brief and give me detailed answers on the questions, right? And don't be professional, be straight to the point, right? Something like that. You can choose to give it a safety or not. But a system message is just you giving the model instructions. So the model is going to follow this guideline, right? Every prompt you're going to give is going to follow the guideline you've actually given it through here, right? So a quick one. I'm using Azure AI Foundry. This is just a platform to play around with models and create uh, fun models to create solutions, AI solutions, right? Uh, some people might think, hey, this guy is biased toward Microsoft. No, it's just that I have credits for Microsoft. It's not like that. I'm biased toward Microsoft. I have credits, and I like the playground. I like the models and the way it actually works. So we've given the model instruction. Let me apply the changes. Continue. I've applied the changes. Now I'm going to go back here and we're going to, for example, now start the basic prompt. Give a tagline for the website landing page. Come on. Okay. We prompt the model. Let's see what it will give us. Gear up, get out, and then I can tell it, can you be a bit creative with your tagline? This is too boring. Let's see. Yeah, this is better, right? And then let's make it better. There's generate more like GPT-4o can generate more accurate and relevant answers if you break down the prompt into smaller parts. Right? For example, write a short, clear message on the home page specifying the company name and the main value proposition. And then I continue, write a brief description of the business, including categories of product offered. And then I continue again, right? I break it down into chunks. Sipei yote all at once because I know most of us unachukuanga assignment unaiweka hapo yote. Paste there. If you break these tasks into smaller, kama unachukua tu question 1 unaipatia. Question 1A, question 1B unaipea. Question 1C unaipea. Pole pole tu, right? I see my time is almost up, but let's finish up with this. You see, it's generating for us our web page, home page, right? So the days of the days of website developers iko chuma kimotoni, but yeah. So as I finish up, there are different tools to play around with AI, and since this is just an introductory course, I didn't want to leave without a short demo. But yeah, the deeper you get as the community, maybe I might come again and show you how to actually do this through Azure in step by step on your own, right? But yeah, as I finish up, I want to say AI will not take your job. It will take the job of someone who doesn't know how to use artificial intelligence. Right. That's what I want to finish up with. Yeah. So yeah, there's someone who has actually sent something. Simply put the role, task, specifics, context, and examples and notes. And always remember to put context, so that the model can be able to understand. So yeah, thank you very much. Anyone who has a question, I think I'm gonna end there. Thank you very much.
Hello.
I think that was very, very good. Wait, Ben, do you have a question?
Yes, I actually, okay, mine is just to add something onto prompt engineering. I like the way you've put the context, I like the way you've outlined how one is supposed to prime their prompts when inserting them into GPTs. So mine is just to add on specifics and context. So this I picked it from an AI automation agency community in school, whereby you need to also like hype, to hype up the GPT. An example, when you're telling it what role it's taking, yeah, you add to it, take a breath and think through the steps. You are a word class, you are experienced. You need to hype it just the same way you would hype a human being. That way you will find that the maximum of performance when outputting the responses will increase by a significant percentage. And that's something that I've tried to, and it really works, especially in GPTs like ChatGPT, DeepSeek, Quen. It really works. It's called emotion prompting, where you just add a bit of hype on top of what you've already scripted as the prompt. You just add a bit of hype. The same way I'll tell you, Farah, you're a very good communicator. Your delivery of points is excellent. That way. Also, to add on that, you can also tell it, your role is crucial in shaping up this company. You just hype it up on top of what you've already scripted as the prompt. Yeah. Thank you.
Yeah, that is actually good. That's actually good.
So thank you so much for that amazing presentation. I'm so sure everyone has learned something new here. and I know you're going to, like, it has sparked a curiosity on what to do next or what to learn next. And I'm sure everyone here is going to go back and probably teach others. So thank you so much, Farah. That was an amazing, amazing session. And we'll be sure to have you back. Yes, we'll be sure to have you back here. And yeah, and I hope the people are happy. So we've come to the end of the session. We've actually Farah has actually kept time. Yeah, and I'd like to ask you guys to please follow our WhatsApp group. We have a WhatsApp group and a WhatsApp channel. So the group is mainly for the tracks. So there's AI, ML, software development, yeah, all those. But the channel is generally for internships or sharing opportunities or any other webinars that might be going on. You can also follow our LinkedIn, and we'll be having these sessions every single week on Wednesday, same time, unless communicated otherwise. So for this series, it's going to be all about AI ML. And for our next speaker, I know she's going to be amazing, and you follow our LinkedIn to find out who's the next speaker. Yeah. So I think that's all for now. And I wish you guys a wonderful evening. Yeah, and don't forget to follow our WhatsApp group and channel. Thank you. They're in the chats. They're in the chats. Yeah. And you can also go follow Farah on LinkedIn as well. And he's also shared some resources on the chat. I can see.
Yeah, I've
Yeah.
shared the introduction to Azure AI Studio, and there are many more resources you can learn. Yeah, and I'm very happy that I hope you've learned something. And yeah, thank you very much for the opportunity.
Thank you too. And I know also next time we're going to have a few more activities apart from the session. There'll probably be a fun activity at the end. Yeah, thank you and have a great evening, everyone. You can leave at your own pleasure.